All right, this is section 10.6, our last section for the school year. Hooray, hooray. So section 10.6 is over samples and populations. We've been talking about probability, but we're going to end the chapter talking about different kinds of samples or surveys that you could take to get data. So a population is an entire group of people or objects, and a sample is part of the population. So if you've ever seen a survey taken, they can't ask everybody. Like, for example, if there was a survey, we were trying to ask all the people in Indiana, all the Hoosiers, and there's no way we could ask every single person in Indiana. So what they'll do is they'll take a random survey of different parts of the state, try to make sure everybody's represented fairly. Obviously, the sample is going to be much smaller than what the population is. That's why it's called a sample, and then we could get good information from that. So you can use a sample to make an inference or a conclusion about a population. So first thing you do is you identify the population, and then you select a sample. Now the sample, again, is the smaller part of the population. And then once you have a sample, you can interpret data from that sample, and then once you have that data, which is really important, you can make an inference or a conclusion or a prediction based off of that data. And that's what we're going to do today. All right, so let's start by making sure we can identify what the sample and what the population is. So in example A here, it says the students in a school and then a students in a math class. So the bigger a bigger amount here is going to be the population. So the students in the school are going to be the population, and then the students that are in one classroom would be the sample. Okay, they would just be one part of the population. Part B, the grizzly bears with GPS collars in the park, or the grizzly bears in the park. Well, the grizzly bears, all the grizzly bears make up the population. I'm just going to use POP for population. And then the ones with the GPS collars, those would be the ones with the for the sample. For C, we've got 150 quarters, or we've got all the quarters in circulation. Of course, there's more quarters that are in circulation. That's the population. And then these 150 quarters would be the sample. And then D, all the books in the library, or 10 fiction books. So all the books in the library would be the population, and then the 10 fiction books would be the sample. All right, so now that we know what a sample is, let's talk about how we can use them. When a sample is selected at random, this is very important that it's done at random, each member of the population is equally likely to be selected. We're not selecting everybody, but we're not leaving a certain part of the population out if we do it at random. There's no bias towards any specific group. So this example says you want to know the favorite extracurricular activity. Now those are like sports or clubs of students at WMS. Determine whether each method will result in a random sample, or if it's not random, of course. So we've got the first one here. It says you ask band members. Again, you want to know what their favorite extracurricular activity is. So you ask the band members. Well, chances are those band members are probably going to say they like band. That's why they're in band. But even if they didn't, you're only asking band members. So that's not random. You're excluding anyone that's not in the band. For example, see, you published a survey in the paw print. Now, anyone could read the paw print, but a lot of people, let's be honest, probably don't, so especially now. So this would be not random. We want it to be random, right? We want it to be random, and this wouldn't be. It's better because you're hitting more students, potentially getting your information out to more students, but it's still just not random. Example C, you ask every 8th student who enters the school in the morning. Now, this would be random, and the reason why it would be random is because you have no control over who walks in the building, but you know everybody does. Everybody walks into the school in the morning, right? Or most people, I guess, unless you're late or unless you have something going on, you're going to walk in the morning. So if you ask every 8th student, you're not just hitting up your friends or the band members or people who read Paul Print, whatever. You're asking every 8th person, and everybody's included or has the opportunity to be included because you're asking every 8th student. And then example D says you ask the students in your success time. Or this would be like SLT. I guess it's the same class, right? So this would be not random, And again, it wouldn't be random because not only you're not including all of the other students that go to WMS, right? We're not just talking about 7th graders, but you're only including the ones that are in your SLT or your success time. So that would not be random. This would not be, we wouldn't want to use that data for a good survey. So to make valid or good, right, valid would be accurate. To make accurate inferences about a population, you must choose a random sample. That's so important. That word random is so important in this section. We want things to be done randomly. You have to have that random sample so that it accurately represents the entire population. Let's look at this next example. A new power plant is being built outside of a town. In each situation below, residents of the town are asked how they feel about the new power plant. Determine whether each conclusion is valid. So if you take a look here, we can see there's a lot of different statistics. They've got charts, they've got a pie chart here, they've got different things to look at. None of that stuff matters if the survey isn't done randomly. So when I'm looking at this stuff in my homework, I don't really actually care about what the numbers are, how many people were for or against or don't know. I don't care if it's 50-50. I don't care what this data is because I have to determine if the survey was done properly. So let's look at A. It says, a local radio show takes calls from 500 residents. The table shows the results. You can see most of the people, I scratched it out, most of the people are against it. Well, let's think about that. You've got a local radio show taking calls. Now, again, this is only going to be calls from people that listen to the radio show. And if you're that motivated to call in, you're probably pretty opinionated, right? You have your strong beliefs, and you can see a lot of people are calling in and saying no. This would be not valid. We wouldn't want to look at the results of this radio station survey because it doesn't reflect the entire population. Again, we know that word population of the entire town, right? It's only the people that listen to that radio station, so that would not be valid. For part B, a news reporter randomly surveys 2 residents outside a supermarket. The graph shows the results. Okay, they randomly do it, so that's good, but how many people did they survey? 2. Well, that's not nearly enough. If you're going to do a sample, it's got to be big enough, more than just 2 people. So I would also say this is not valid. You can see the results were 50-50. Well, that's because they only asked 2 people. So one person said they liked it and one person said they didn't. That's not enough information. But again, I'm not even looking at this information. I'm just looking to see how the survey was conducted, and it wasn't conducted very well. And then example C, you randomly survey. Okay, randomly, that's a good word here. I like the word random. 250 residents. Well, that's a large amount of residents there. At a shopping mall, the table shows the results. And you can see the results are still, you got more people that are against it than for it, but you randomly did it, right? And it says at a shopping mall. Well, most towns only have one shopping mall, and you're going to get a lot of different people that go there. So this would be as valid as you could probably make it. You're not going to be able to get to everybody because not everybody goes shopping at that mall, but a lot of people do. And you're randomly doing 250 residents, right? You're going to get all kinds of people from the town. You're not just going to get the angry people, but you're going to get everybody if you do it randomly at that shopping mall. Let's look at our own one here. It says you want to know how the residents of Kokomo feel about a ban on texting while driving. Determine whether the conclusion is valid. You surveyed 200 residents at random. Again, that word random is in there. That's usually a good sign. 200 is a large amount. That's good. 164 of the residents support the ban. 36 don't. You conclude the 82%. Again, the stats don't mean anything to me. Was this survey conducted randomly? Well, it says, yeah, it was. So these would be valid results. And there was enough people, right? There was 200 people, not just 2 people. Example B, you surveyed the first 15 people who drive into your neighborhood. Okay, well, your neighborhood isn't Kokomo, right? Like, it's part of Kokomo, but it's not all of Kokomo. And you only surveyed the first 15 residents. That's not a large number, and it's only in your neighborhood. And you can see 5 support, 10 do not, don't even care about those results. That's not going to be valid. It wasn't large enough, and you didn't randomly do people from the entire town. You just did people in your neighborhood. Okay, so the real vocab words we have from this section are biased and unbiased. And the first one we're going to look at is unbiased. An unbiased sample represents the entire population. It is selected at random and is large enough, right? We talked about don't do too small. It's large enough to provide accurate data. So we like unbiased samples. They are what we want. We don't want our samples to be biased. We want them to be unbiased. So unbiased means good. And that's what we're going to refer to from now on. Instead of saying valid or invalid, we're just going to say unbiased or biased. Unbiased surveys are good. Unbiased samples are excellent. And of course, biased means bad. Biased, we don't like biased. The word biased, if you're biased towards something, for example, if you ask me where we should spend more money at our athletic department, well, if I'm a football coach, I might say football, right? I have a bias towards that. If you were judging a talent show and your friend comes on, you probably have a bias towards voting for your friend versus anybody else. Those are biases, and biases are bad. We don't like them to be included in our samples. So a biased sample does not represent the entire population. One or more parts are favored over others, and we don't want that. That's not random. So this next example says you want to estimate the number of students at the Western High School who ride the bus. Now this is the high school. Determine whether each sample is biased or unbiased. So you ask 4 students in the hallway. Well, my guess is you only ask people that are around your locker. Now, assuming you're a high school student, right, that's at the Western High School, and you only asked 4. It's not large enough. So it's not a large sample. And so I'm going to say this is biased because you didn't do it randomly. It's not large enough. You're only getting people in that particular hallway of the high school. Example B, all students in the marching band. Okay, so it's definitely large enough, but you're only asking people in the marching band. And let's be honest, I don't know how many of you guys do marching band or have had siblings. They probably don't ride the bus because I always hear them out at Western practicing at like 6 in the morning. So they probably don't ride the bus. This is going to be biased again. Again, biased means bad. We don't want that to be our surveys. I would not want to only ask marching band. Not that I wouldn't ask any marching band, but I can't say I'm going to ask only the students in the marching band. That's just bias. That's me favoring one specific student group over the others. Next one says 50 seniors at random. That word random in there is good. However, you're trying to predict or take a sample of the entire high school, and you only asked the seniors. You didn't ask the juniors, the sophomores, or the freshmen. This is also biased. You did it randomly. That's good. But you left out 3 important parts of the population. And then last one says 100 students at random during lunch. Well, it's done randomly. It's definitely large enough. And you did it during lunch. Every student has lunch as a class, right? They don't all have band. They don't all have PE or choir or whatever, but they all have lunch. This is unbiased. Unbiased is good. We want our samples to be unbiased. You want to estimate the number of 7th grade students at Western Middle School who consider it relaxing to listen to music. Who doesn't think it's relaxing to listen to music? It says determine whether each sample is biased or unbiased. A, you randomly survey 15 members of the band. Not only do I think 15 is a small number, again, you're only asking people in the band who probably like music, right? They have a bias towards music. They're taking band. This is going to be biased. Biased equals bad. They both start with a B. Biased is bad. We don't want that. We want to ask people in the band, but we can't only ask people in the band, and we have to do it randomly. Now, you did it randomly, but you just included one type of people. Next one, your friend surveys every 5th student whose name appears on an alphabetical list of all 7th graders. So everybody's included on this list. You're not asking everybody. You're asking every 5th student. So that's random, right? You don't have any control over that. You're not leaving anybody out because you're making your way all through this entire list. You're not leaving anybody out. Everybody has the opportunity to randomly get picked. So this is going to be unbiased. It's large enough. Everybody had the ability to get picked, unlike the last one where only the band members could get picked there. Everyone had the opportunity to get picked. It's large enough. This is done randomly, and it's unbiased. So assuming we have our unbiased samples, we can use those results because the results are going to be proportional. Gosh, we've done so much with proportions this year. The results are proportional to the results of the population. You can use unbiased samples, have to be unbiased. Unbiased is good. You can use unbiased samples to make predictions. That's what we do with proportions. Whoops, I did not spell that right. Let's try that again. Predictions. I think that's better. You can use unbiased samples to make predictions about the entire population. This is what people use surveys for. They use proportions, and then they make predictions about the entire population, even though they didn't ask everybody. So let's get our proportion hats on. It says you ask 75 randomly chosen students how many movies they watch in a week. Well, right now we're probably watching a lot of movies at home, not movies at the theater, but I'm watching a ton of movies at home. There are 1,200 students in this school. A, predict the number of students in the school who watch one movie each week. Okay, I need these numbers up here. You asked 75 people. There are 1,200 people in the school. Well, let's look at the results here. The results say, because you're looking for people who watch one movie, 21 people watched one movie. So how do I set up my proportion? Well, the first thing I would write, the first ratio I'm going to write is the sample ratio. 21 out of 75 people said they watched one movie. Where did I get 75 from? Well, I told right up here, that information was given to us. It was told to us at the very beginning of the example. And we know 21 out of the 75 people said they liked it. So if 21 out of 75 people said they watched one movie, then how many out of the entire population, which is 1,200, do we predict are going to also watch one movie? So remember, to solve a proportion, we do our fancy cross multiplication that we always do. 75 times x is 75x. And 21 times 1,200, get my calculator out here, that's 25,200. That's easy enough to type in your calculator. Then we just have to divide by 75. And when you divide by 75, type that in real quick, you get 336 students. That's my prediction on how many students out of the entire school, not just our population, but out of our entire school, watch one movie a week. Now let's do the same thing, but now we're going to do the ones that watch 2 or more movies, okay? And that's 24 people. So we'll do the same thing. Just if you didn't catch it the first time, maybe you'll follow along this time. So let's look at our sample. 24 out of, remember, 75. We asked 75 people. So 24 out of 75 people said they watched 2 or more movies. So how many people out of the 1,200 in our school are going to say that they watched 2 or more movies? So we cross multiply again. 75x. 24 times 1,200 is 28,800. That's a comma there. And then I'm going to divide by 75, and that's going to give me 384. That's more people, and that makes sense because more people in my survey, students, there we go. More people in my survey said that they watched 2 or more people. Actually, a lot of people said they watched 0 movies in a week. That's crazy. I don't know how you could get by with doing that. And we'll finish with one last one and then look at a homework problem. It says you ask 50 randomly chosen students at Western. This is a good sample. It's unbiased. To name their favorite sport. There are 680 students in the middle school. Predict the number of students in the school who would name soccer as their favorite sport. So how many people in our sample said they liked soccer? That'd be 12, right? 12 out of how many? Well, they're making us do some work here. I got to add these up. How many people were asked? 8 and 12 makes 20, and then 20 and 10 makes 30. Altogether, that's 50. And you know what? I just realized they actually told me right up here. I feel really silly now. They just told me that they asked 50 people, so I didn't have to do that. So I just caused myself a little extra work, but no problem. So if 12 out of 50 people said they like soccer, then how many out of 680 students in our middle school would say they like soccer? And so we're going to cross multiply. 50 times x, of course, is 50x. And 12 times 680 is 8,160. And then I'm going to divide that by 50 to get 163.2. So I'm going to say, because you can't have 0.2 of a student, I'm going to go ahead and say in just 163, that's what it would round to, because 0.2 stays low there. 163 students are going to say they like soccer as their favorite sport. Let's finish with a homework problem number 19 from tonight's homework. It says a guidance counselor surveys a random sample of 60 out of 900 students. Using the survey results, the counselor predicts that approximately 720 students plan to attend college. Do you agree with her? She said 720. Let's figure out if she's right. Now, one thing that makes this circle chart or pie chart different, you can see they give us the percentages. They're already giving us percentages. So when it says 75 people say yes, that's not people, that's percent. It's 75% said yes. And so I'm not actually going to use a proportion for this one because it's already in percentages. Instead, I'm going to do something a little bit easier. Okay, 60 people were randomly surveyed, and 75% said they plan on going to college. So if 75% of my sample said they were going to go to population, then if this survey is done randomly, which it was, then I know that 75% of my population, which is the 900 students, are going to plan on going to college. And so I can turn that into a decimal. I can change of into times, one of the things we learned this year. And then I can put the 900 down, and then I'm going to multiply 0.75, 75% of 900. And 75% of 900 is 675 students. And what did the guidance counselor say? The guidance counselor said 720. I'd say she was probably off a little bit. Let's look at our options here. Yes, if you take the percentage of a student plans to go to college, 900, approximately 720. I don't agree with that. I would say that's probably wrong. No, the number of students plan to go to college is 45. No, 675. No, the number of students should be represented as a range because you don't know whether the student said maybe will be attending. I don't think that's true either. And the last one says no, the number of students planned, it's going to 675. Boom, there's our 675. It's got to be that option right there. So no, we don't agree with her. She overshot it by quite a bit.